Before we begin, anybody who would like to take notes for this session? We won't be able to start unless we have a note taker. Thank you. So this is a TSV working group, the second session. We are in a very small room this time, so please squeeze in, don't leave any free seats so that everybody can sit down. And this is the note well. You should know this by now. It contains our policies regarding intellectual property and our code of conduct and other things. Please familiarize yourself with this. This is the agenda of today's session. This is the first slide of the agenda. This is the second one. We will start with the DTLS SCTP work. And after that, we'll discuss careful resumption. And then we will hopefully have time to get to 2 individual drafts about signaling things to the network. Any agenda bash? That is not the case, so let's get started. Is Michael here? He is here.
I'm remote.
I'll get up your slides.
Okay, this is a status update for the work of updating SCP authentication. Next slide. This is the scope, at least my understanding of this scope. Take the RFC 4895 as is. Incorporate relevant changes from this document, which was an individual contribution some time ago. Then address 2 security issues, which have been reported by Ericsson. One is related to the directionless or the not directionless of the keys, and the second is that keys will be used with different HMAC algorithms. There was the proposal on the list to generalize HMACs to MACs, because the document always talks about HMACs and you can have different ones, but sticking formally to HMACs. Have more algorithms than the one which is specified, potentially retire HMAC based on SHA-1, and add some socket API considerations for improved control of the SCP auth messages. The current state or the current socket API is specified in the big RFC, which defines the socket API, because that was done later than RFC 4895. Next slide. So here you see the history. The first 6 things were individual contributions. The 00 document was the same as the last individual one, only submitted its working group document. The 01 incorporated the older BIS document, some editorial changes, and an update to the IANA section. And the security issues were addressed in the second, in the O2 version, where I basically describe how to use directional keys in the same way as it was done in the RFC 4895, so there were no style changes. Next slide. This is the initial handshake, just to refresh that. If you want to do SCP authentication, you add a random parameter to the init and init ACK, which can contain an arbitrary long random number, and it's required for the algorithms used here to be a 32-byte random number. A chunks parameter, which basically lists the chunks which will only be received by the sender of this parameter, and an HMAC algorithm parameter, which says which HMAC algorithms are allowed to be received. Next slide. So this is the updated key management. The first thing is that both sides exchange random parameters, and the handshake is modified in a way that the parameters are different. So this is easy to get when you have a client-server thing. So the client chooses a random parameter, and the server chooses one which is not the one received. The critical point here is if you have a collision of the init chunks, so both sides act as a client, then in the case of both sides choose the same 32-byte random number, you might need to change, send an abort and choose a different random number. But this is very rare. Collision on 32-byte random numbers is pretty rare. From that, you create a local and remote key vector, basically by concatenating the random parameter, the chunks parameter, and the HMAC algorithm parameter. You do this, the local key is based on the parameters you send, the remote key is based on the parameters you have chosen. So both sides have a local and remote, and the local of one side is the remote of the other. And in this case, they are different because the random parameters are different. Next slide. From that, you concatenate, by concatenating the key vectors, you get a send context and a receive context, and then you get a send key and receive key by using a key derivation function, where you use the send context or receive context and a shared key. The shared key is what is configured only via the API, so both sides can configure multiple shared keys, and you derive the send key and receive key here using the key derivation function from RFC 15926, which is a CTP, TCP authentication function. There is one special case. The special case is when the key ID is 0, which means the shared key is empty. That is if you start right at the beginning and you don't have anything else. The text in the document is not as generic as given here in the slides, but it's done explicitly using HMAC SHA-256. Next slide. There is backwards compatibility. So a node which supports the BIS document can interop with a version which supports only the old version, as long as it's enabled by the upper layer explicitly. And then the send and receive key are computed by the minimum of the local key and remote key, the shared key, and the maximum. So in that case, we don't ensure that the random parameters are different and the send key and receive key are equal. This is putting the old way in this formal context. Next slide. The auth chunk is then computed by using a MAC based on the send key and the chunks, and that is not changing between RC 4895 and the BIS document. Next slide. So the next steps, double checking here, because there was some discussion on the mailing list. The intention of 4895 has not been to improve the replay protection of chunks with sequence numbers. So it only makes sure that you accept chunks which have been sent, and you use the replay protection from the base protocol. If we want to change this, that could be done, but for example, you could do sequence number extensions, but you need to do this then for reconfig chunks, ASConfig chunks, and data chunks and sub chunks. However, the one use case for this is DTLS, where data chunks are relevant. Another use case is address reconfiguration, and so you don't have the sequence numbers for the data chunks. So this is right. So this is this wasn't intended by the original spec, and right now it's unchanged. What I plan to do is to use a formula-based description of the key handling, similar to what I did here, and then it is pretty easy to generate from HMAC to MAC. It's a change which will address names of protocol elements. It will change socket API names. So it's a larger editorial change. So that's why I wanted to delay this. And we can add more algorithms. I just right now added HMAC SHA-256 in a directional way. And of course, I go through comments received and upcoming comments. The comments received, I try to address and give at least some feedback in GitHub. That's it from my side. Any questions, comments?
John, I personally think that the replay protection for data, that there should be replay protection for data, but if you don't add that, I think it's very essential that the draft describes that you don't have any replay protection. I think what is stated here is not really improving the replay protection. I wouldn't put it, I would say not improve the duplication handling or something. I think SCTP and SCTP auth does not have replay protection in a security sense. I think the right term, if you don't fix this, is that this SCTP auth does not provide replay protection. And then you can fill in with like the deep duplication and so on. But yeah.
It makes it so it tries to say it already, I think, that it doesn't improve it, but we can if you think the wording is not good enough, we can change the wording.
Okay, yeah, I will review and comment on that.
Any comments on add more algorithms?
Corey?
How long do you think you'll need to finish your next steps if people provide inputs?
Change to a formula description, generalize HMAC to MAC. By the next IETF, we can have that. I think I put some text in the issues raised already. So they are GitHub issues. We can address them. Add more algorithms depends on feedback I get. So I won't go through an arbitrary list and add more algorithms without getting any suggestions. I mean, we could go with the algorithms which are used by TCP/AO.
Okay, that was helpful. Anyone else want to comment on any of these topics? Thank you, Michael. That looks like good progress. So the next topic is a report back from our design team. This set of slides has a lot of information in, and it's being presented here to help the working group. So if at any point in the talk you think it's helpful to ask a question, please join the queue. If you think you have an idea that is different to what's being presented, please also join the queue. The purpose of the design team is for us to make progress, particularly with the requirements. So over to Magnus to try and show us what they've been doing.
Yeah. So, okay, I'm here to report on the design team. So we can go to the next slide to see who were involved in the design team work. And then get on to the next people, the next slide. So when it comes to the general requirements, the design team discussed this before New Year. We had a fairly good understanding already by the last IETF when we presented the last time. And so we do think what we know what our view on the 3DPP needs, what's been discussed by the contributors in the design team. And what we did after the IETF was just discuss a bit more and assign some priorities to certain aspects. And that was captured in that PowerPoint slide on the GitHub as a working material. So let's go on to the next slide. So we have worked with 3 proposals on the table. A is what the current working group document set, which is an update of 6083 with and is contained in the details of STP BIS document in from the working group, and also has a dependency on updated STP auth. Proposal B is Ericsson's proposal for updating or replacing that proposal, which is covered in 2 parts. There's one details chunk covering the aspects which goes into the STP stack, and handshaking and rekeying functionality on top of the STP stack. So draft Westland TSV STP details handshake. Then we have the third proposal, which is C, which the primary proposal comes from Michael Taxon and Hans Schofenning, but it's also others involved in that, which is draft Taxon TSVD 683 BIS. So this is also based on similar structure as 683 BIS, but it has then one thing for dealing with the user message fragmenting, which is this PPID fragment, which is a separate function, which could be used in other contexts too. So that's a separate document. The STP OAuth update, and a key update proposal, which has been proposed to the TLS working group, as well as using RFC 9261 for periodic authentication. So that whole set of documents is what's C. So, okay, let's go on to the next slide. So the analysis which design teams agreed on is that all of the free solution proposals meets the design team's agreed technical requirements. The proposal differs in some technical details and properties. We will look more on them later. There's difference in what IPR claims exist and their impact, for example, on potential to do open source STP implementations. And the expected timeframes to complete the work here in IETF. So, and we'll go through each of these now. So next slide. So when it comes to the completion time, for A, this would all be work done in TSVWG. STP OAuth needs to be completed, as well as the updating spec needs to be completed. The estimate from the driving authors here is that this work could be ready for publication request by the end of this year. For B, all work would be in TSVW working group. And also here, we could expect to be ready for publication request by the end of the year. When it comes to C, there's dependency on this adopting this key update in TLS. This was discussed before this in this morning. It was not ready to be adopted at this point. So that may further delay this estimate on timescale. Also here is the need for STP OAuth need to be completed. And the also here, kind of the estimate was that the TSVWG parts could likely be ready by publication by the end of the year. However, so the really long, the question of how fast this could be completed in IETF is depending on the key update parts. So maybe anyone wants to fill in anything or comment on what happened in TLS this morning? Or should we take that afterwards? So, yeah, go ahead, John.
Yeah, John Mattsson, there was, in general, people seem to mostly like the idea of doing it. People did not, quite many people did not like the changes from 0.0 to 0.1, especially doing things on the application layer. So I think the consensus was that this needs more work. And then I think it depends, depending on where there was also a lot of discussion about formal verification in the TLS work. If you would do any changes to the key schedule, for example, you would likely require formal verification, which probably takes a year by itself. Yeah.
Okay, thank you, Jon. Any additional comments on this?
Yeah, the change between 00 and 01 was the suggestion, the proposal in 00 was to do it in the TLS layer, and the feedback we got on the mailing list was to do it above. So that was then changed in 01, and the feedback, that was the feedback on the mailing list. So the feedback in the room or during the session was that people liked the approach in the 00 version more. So it was changed due to feedback, but that feedback changed, or different people provided feedback.
Okay. Let's go on to the next slide. So when it comes to IPR, on solution A, there's 2 IPR disclosures with fair, reasonable, and non-discriminatory terms. You see the IPR declarations there. On B, there's a bit more complex situation. On the part that goes in the STP stack, there's a defense declaration with the option of fair, reasonable, and non-discriminatory terms. Please read the disclosure. And for the handshaking and key establishment and rekeying, there's another disclosure which is just friend. So on C, there's currently no IPR disclosures. So that's the situation there. Next. Now so a little bit about the implication of this IPR. So basically for A, you would likely need to do 2 RAN license applying to any implementations on the top of the SDP stack for these DTLS for SDP functionality. For B, so depending on here, it's the part that's in the SDP stack, which has the defense declaration. And if you meet those requirements, you wouldn't need a license. But and this license was written in this way to try to not impact kernel open source. And then you also would need a RAN license on the rekeying implementation on top of the SDP stack. And as I said, C has no current IPR declarations. Next slide. Okay, Martin.
Martin Duke, Google, no hats. So you're doing your own rekeying thing here. If I understand correctly, this has a rekeying method. Option C has a rekeying method that will require formal analysis in TLS. Does this require formal analysis, or does it somehow evade that requirement?
I would say, let Jan respond a bit, but I would say
the rekeying in solution B is just DTLS resumption, so there's nothing new at all. Yeah.
Yeah. Okay, good. So on the more details in regards to what the differences on proposal A. So A is depending on the TLS 1.3 features, and that includes the TLS connection ID. But we have noted that we could do a fairly simple re-engineering of that to avoid the need for the DTLS connection ID. The kind of biggest issue we've had here is around rekeying. And because the DTLS messages, the upper layer message being sent is protected by DTLS, and those messages might be sent over different streams at the same time, etc. You have a bit of a tracking to do to figure out when all DTLS records protected by an old key has been passed over to that end and processed, so they no longer need the keys before you close it down. And that's one of the challenges in these proposals. And that also, especially if you're having the RFC-based SDP auth APIs, socket-based IPA for SDP auth, this becomes a bit, that puts further limitation on this when it comes to how many messages you can transmit, etc., and knowing when the data is. So, but with the exception of SDP auth functions, all of this proposal resides on top of an SDP stack. It's between the upper layer protocol and the main SDP parts. And it relies on STB stack for the application, etc. And as Jan commented, it's not really replay protection, but dealing with any duplication of packets, etc., or replays, they come into the stack, and this does nothing to change the properties of the STP's handling of or dealing with this. There's two crypto passes. There's DTLS over the user layer protocol user messages, and then it's STB off over the STP packets chunks that are signaled to be protected by the auth chunk. So let's go to B. In B, we have one DTLS record per SDP packet. Simple rekeying because it's done in transmission order. We are using DTLS record sizes that are on IP MTU size level, which is common to other DTLS applications. The point here is saying that an off-the-shelf DTLS stack is likely to work with, to just function with these requirements. And then we also get the TLS replay protection, preventing STP stack to having to process replayed old packets. So it actually improves the STP stack's protection of that stack and from attack. And there's only a single crypto operation pass for the DTLS protection of each packet. And this thus encrypts both the STP protocol as well as the upper layer protocol data. The DTLS record processing is integrated into the STP stack, which means that the kernel STP implementation requires kind of a split DTLS implementation, where you have the record processing integrated into the stack, and then you provide it with keys, etc., and do the DTLS handshake over the STP stack. There's one limitation currently, which is compared to IP's maximum MTU of 64K. We have a current record limit of DTLS will be the maximum STP payload MTU of 16,384 bytes. And if this proposal is taken forward, it would be raised to 64, and there will be no impact on regular IP. So, next. C. When it comes to C, it fragments the ULP user message into multiple SCTP messages. And this has slightly stricter requirements when it comes to what you can do. So it requires in-order reliable delivery on the streams. So if you have large message, you can't do partial reliability in that way. But it also gives you benefit, basically saying that you can get iData-like interleaving between streams of ULP user messages. It re-authenticates the peers with using RFC 9261 mechanism. And here, what we learned is like, okay, we haven't found an open source implementation currently available for it. We know, however, that at least one of these, they're not particularly large, and at least one is no more than around 300 lines of code. And just like A, it relies on the STP stack for handling any duplicated or replayed packets. And also in this case, it's two crypto passages like A. So it's DTLS over the ULP user message and STP off in the packet chunks. So Martin.
Yeah, me again. Are there any open source implementations of like the legacy DTLS over SCTP solution that you're replacing that you know of?
Yes, it's implemented in OpenSSL.
Okay, so if I understand correctly, the IPR applies to DTLS over, not for, I mean, the IPR for A and B applied to DTLS over SCTP, not SCTP. This would not affect SCTP in the kernel. It would affect OpenSSL or whoever else happened to try to do this open source.
So you could implement C
No, yeah, C is no IPR encumbrance, if I understand correctly.
Yeah, but you can't implement A or B. B is something else because B is a split thing.
So when it comes to B, basically what we were trying to nail down how it's like, yes, it's possible to implement the kernel part in the kernel,
Yes.
but Michael, etc., has expressed that it's, yeah, their
Okay,
personal preference not to do this because of yeah.
No, I get that, but the real world impact would seem to be, well, okay. So there's the let me back. So how many DFS over SCTP implementations do we know of? There's the OpenSSL one. There's the Ericsson one. I mean, not of these new proposals of like the legacy thing.
Yeah, I don't know if there's anyone else that has one.
Okay. So we think Ericsson and OpenSSL. So Ericsson is obviously fine with Ericsson IPR. So the effect is on OpenSSL and anyone else who should choose to venture into this space. Okay, thanks.
Okay, let's go on. So we're now coming up towards choosing a solution here for way forward. I think the main choice really is between timely completion and potentially IPR-free. And the 3DPP has stressed in the analysis back to the working group that they want to have a solution quickly. Both SA3 and RON3 has said that, quoting the relevant part of analysis. And basically the choice here is for timely completion as between either A or B. And if you're going for IPR-free, C would be the candidate. So next. So this table tried to summarize kind of the main points here, what's included in the different, what's the IPR, what's the time frames, etc. So, and implementation aspects. So, so I guess we can go to the Gori.
Yeah, I just wanted to check that the people in the room agreed with this table, because this table is a great summary of kind of where the design team has reached. Does anybody have any comments on this table or the implications of the things in the table? Does everyone agree with them? Do people think there's maybe some questions about whether the time or the IPR is correct here? Are people happy? Just general questions, just trying to get a sense of what people think.
A comment from me looking
Okay,
at now,
okay.
based on the for solution C, I think there's this at the end of 2025 TLS is very aspirational at the moment, considering how it developed for this meeting. That's so, but
Yeah, go ahead, Magnus. Because Martin.
Yeah, sorry, I didn't bother because nobody else is going to the mic. Has anyone contacted OpenSSL and gotten their feelings about this?
no, I haven't.
Okay. I don't have a super strong opinion about this, but I do feel like we may. I would feel really good about A or B if we felt that there's no, like, if the IPR issue was purely theoretical, I would feel a lot better about A and B, which is not to say I say we can't do A and B without that, but that would be an interesting question to answer.
Jahed. Yes, I don't think we have talked directly with OpenSSL, right? So, but just, I mean, it's not like really theoretical, that point of view. The IPR does impacts. I think that there has been a fair amount of discussion between Magnus and Michael to understand what exactly that means. And my understanding is like, this means like for OpenSSL or anybody else to implement it, they need to have a license to make it happen. There is no other way around for A and B. But for the open source part of the open source part that's going to the HTTP stack, people can implement it. I think for Michael and Marcelo, that's like Red Hat, saying like, okay, we can implement it, but we cannot really ship a test client to test it. So we're not gonna do that. So that's basically the situation we have.
Okay, I'm sorry. So did you just say like we cannot actually deploy it to the kernel because of this testing issue?
I think that's what we tried to discuss on the mailing list, is saying that depending on how you do the test client, I would saying that there's way of doing the test client that doesn't infringe the IPR.
Okay, so that's a matter of technical dispute at this point.
Yeah.
All right. So by theoretical, I mean, so obviously the license is real, or the IPR is real, but I can imagine a number of answers from OpenSSL. Okay, so I mean, like I would not be surprised if the hypothesis was that no one knew was going to implement this. So if the OpenSSL people said, you know, we're not going to update this anyway, or like, no, we already have a happy relationship with Ericsson and we license their stuff all the time and our lawyers are friends and, you know, no big deal. Like that would be a great thing to hear. Again, I don't want to say like if those things aren't true, we couldn't possibly do A or B, but I'm just trying to figure out what if it turns out Ericsson's the only people that can implement this anyway and ship it, like let's just do it.
So let's try to clarify this. I mean, what's expected to happen here is that IETF selects a solution.
Yep.
3D adopts it, which means that those implementing products with that interface would need to support this specification.
Mm-hmm.
And at that point, they would need to ensure that, okay, how do I get an
So are your competitors using OpenSSL then? Is that what's going on? Okay, got it. Thanks.
some of it at least. So, okay, maybe go to the next slide where we had some. Oh, we have a queue. So, John.
Yeah, John Mattsson, Ericsson. I think the time estimate is the most essential on this slide. Both LSs from 3DPP, from SA3 and from round 3 stress the time estimate. And this has already taken far too long. We need to ship at least one solution soon.
Corey.
So I'm going to ask 2 more questions just to see if anyone in the room jumps up to the queue. And the first one is, how important is having a solution that's not got IPR to people? Is that something that people feel strongly about, having a solution which doesn't have IPR? And we'll come to this in the next slide as well. And the second one is, do people agree with the timing requirement from 3GPP? Because they've stated timing requirement. So if there's something that says that the IETF should also be considering things on a slightly longer term, then I think I'd like to hear that, because if we have one urgent need, that's important input. If we have other people who think that they can wait longer to produce an IETF spec, then that might be a helpful input as well. Just asking these questions at this stage. You can carry on with the next slide, but please try and think about these things as we carry on.
Yeah. Yep. Charles.
Charles Eckel. Not so much my personal opinion, because a lot of this is a bit beyond me, but within SA3, I brought it up at the 3GPP meeting just to get a sense of the room there. And when we talked about timing, I got confirmation that, basically the sooner the better, and it's already too late, like we need it yesterday type of thing. When I asked about IPR, it was just like we're not really wanting to talk about that. Like, that's it's business as usual, sort of. So I didn't get a strong sense that the IPR was a concern, or at least it wasn't a topic of discussion there.
Thank you. So we could go to the next slide where we have some of the views from individuals in the design team on preferences, etc. So Ericsson's preference list is most preferred solution is B, then A, and least preferred is C, with the motivation that C is expected to take too long. Nokia expressed preference for C, and slight then of B over A, but the FreeBSD maintainer just said it's C or not really any other preference. So, and we can comment that really only implement half of B. And the similar was expressed by Red Hat Linux and upstream SCTP stack maintainer. And the TLS implementer also said C. So, Martin?
So, is anyone actually going to speak up for A as their preferred choice? It doesn't seem like that.
No.
Okay. So,
I think it's between B and C.
Yeah, there's a question to you, but also the room. Okay, it doesn't seem like anyone is jumping up and screaming for A. So, okay, well, that makes it easier. Go ahead, Gory.
Yeah, I just wanted to actually call that one out, Martin, and actually ask if anyone now thinks that A is a sensible thing to have on the table. Are there things in A which you want to keep on the table, or can we remove A? So does anybody want to speak in the chat or in the room just saying that we want to keep A on the table and say why?
See no one getting up. So
Michael's in the list.
So if we have a choice between B and C, means in C no so this will be in the SCTP part is basically doing SCTP auth stuff. For C this is different. For A that would be the same. So for the SCTP part, for open source implementations, A and C are very similar. I mean, they are identical. That's the only part. Whether you will see support for B in open source SCTP implementations, in open source kernel implementations, that's a question. Which was for Red Hat, I interpreted this table as no. Formally, I mean, I think with a defensive IPR statement, it could be implemented in FreeBSD as long as it can be disabled. But as Magnus said, it looks a bit. I'm pretty resistant to implement something which has a single use case, and I can't test this single use case. I can do other tests, I can do unit tests, I can do fuzz testing, whatever, but I can't test exactly the use case which this is intended for. But as I said, that's my personal preference, but the Linux maintainer shared that.
A comment there, Michael. I hope that this will be clear when the IPR we're talking about is public, that you will understand what you can and cannot do. So, but yeah,
But I can't build a
You can't build a full solution,
DTLS
no.
implementation, which you can just put your upper layer on top of, and it just works.
As that bar covers the rekeying, you could build an implementation that supports a solution without rekeying, but
yeah, but the rekeying is the interesting part in combination with SCTP, because you have the auth handling there, the auth key handling. So the interesting part from an SCTP perspective, I mean, you get the encrypt decrypt right or wrong, and you will detect that very fast. But the key management is what is interesting.
I'm sorry, clarifying question. Michael, thank you for that reply. I didn't get all of it. Are you saying that A is potentially implementable? The kernel portion is potentially implementable for A, but not for B?
The kernel portion is the implementability of the kernel part for A and C is identical.
Okay.
For B, you could implement the SCTP part could be implemented in a FreeBSD implementation, I think. But the question is whether this would be done, because the only use case you have, you can't test. And you need to specify an API, you need to implement the API, you need to make sure that the API is good enough and it's actually working. So it's about the testability. And for this functionality, putting the DTLS crypto stuff in the SCTP stack, this is the only use case, at least right now. So it's suboptimal that you can't test this by having the appropriate upper layer.
So would you prefer A to B?
I was just saying, I mean, I would prefer, would I prefer A to B? Maybe.
Okay, this has got a lot
I mean,
muddier. Thanks.
for A to, between A and B, I would implement the kernel part of A, because that's auth. That's the same as C. That's what I have. That's where my problem is with B. I can implement it, but I can't test if it's really working in the use case. So that's why I would prefer A over B.
As we're doing this, just to get another dimension, I started a poll. We're just going to use this to help other people comment if they wish. We're not actually polling on the solutions, we're just getting a sense of the room. But go ahead, Magnus, if you don't have a queue in the room, go ahead.
I have one person at the mic. Hang.
Oh, go ahead.
Go ahead.
Yeah, Han from Huawei. Actually, I think that's the only solution B can do the one crypto path. The solution A and C need to do 2 crypto paths, right?
Yep.
Yeah, and I think so the option B is best performance and kind of integrated DTLS and SCTP makes it more look like quick. And quick is good. So I think we can go this direction. Yeah.
Thank you.
I'm sorry, Magnus, on your slide, what is TLS implementer?
Hannes Schofening.
No, I know who Hannes is, but like.
Yes, it's his preference.
But like what TLS what TLS implementation are we talking about?
Embed.
Okay,
He
which is the one
talked
used
about,
by.
He originally talked about embed TCP TLS, and at the last meeting he said he would focus on OpenSSL. Yeah. Because I think Siemens is more dealing with OpenSSL than with embed.
Okay, thanks.
TLS.
John?
Yeah, John Mattsson, Ericsson. Going back to what Huawei said about layers, one of the comments in the TLS working group today about the key update was that doing security on 2 layers is rather complex and likely to go wrong. Using a single layer is much simpler to implement and easier to analyze. I think that is from a security point of view, that's a big input to this selection. Solution B is a single layer and much easier to analyze. I would say that RFC 6083 doing security on several layers is I think it's a very likely reason why the issues was undetected for so long.
Okay, Gori, you want to conclude on this show of hands?
Yeah. If it helps people, we should record the show of hands. There were 8 people said could go ahead without proposal A. 1 person said we shouldn't go ahead without proposal A. And 8 people had no opinion in this particular poll. Does the 1 person who said no want to add anything else? Speak now. Okay, right. Well, that we will take as input to our decision. Carry on, Magnus.
Yes, but I think the only thing we basically have left is sort of saying concluding the design team and going to, I think, a selection discussion, way forward discussion.
So rather than go to the next slide, let's leave this or the previous slide. Do you want to put the previous slide up for a second?
Yeah.
Mike, Martin? Yeah, that's good. Okay. I would like to suggest that our design team has done a great deal of analysis, and I would first of all like to ask a poll question to check that we agree on the requirements that they've presented. Does the working group agree that the design team has captured the requirements for this analysis? Please vote yes or no. Going to close it in 30 seconds. Martin.
Martin Duke again, no hats. I didn't vote in the previous show of hands, so I was not the no. Regarding option A, I'm still struggling with this, and I'm very persuadable on all these points, but it seems quite problematic to have IPR impairments in the kernel, much more so than with this DTL server SCTP thing, which is going to be a small number of vendors. And if you'd forced me to vote in the past show of hands, I might have voted no for that reason. So I guess I'll stand in for the person who voted no in that sense.
Okay. I mean, I think it comes down to it's what at least from my perspective trying to show is that yes, it is implementable, but yeah, it might not be desirable from some of these working daily, etc. But I think it's possible to get it be implemented in the kernel, even in a open source implementation. That's
yeah. I mean, chair, stop me if I'm going too much in the weeds here. But like, is this an issue with like an automated test that we can't ship because, or like, is it really not possible to even test it for initial correctness?
You can
without-
test it. It's if you would actually publish your testing code publicly, you might infringe the IPR if you do certain
I
things.
see.
So
So Michael, is that something that like do you like ship BSD testing code or publish it somewhere where this would be an issue, or is this solely like your discomfort in getting it going and working in the first place?
So I can't speak for the FreeBSD project, but the testing code I use is code I publish. So that's where I'm a bit hesitating to say I would implement this. I mean, you can use API tests and packet drill tests and this kind of that. That's no problem. But what bothers me is that I can't test the implementation with an upper layer, which is the only use case. If I would have 1,000 use cases or 10 or whatever, so I can't test everything, I would be happy to use one and see what happens. But this is right now, this is a single use case because basically you have a combined implementation. Part of it is in the SCTP stack, part of it is on top. And if you have a userland stack, that is simpler because you can put it below the SCTP stack. So that's my point. I think Marcelo was also going in that direction, but I wouldn't. I don't remember he said that explicitly. Marcelo is one of the Linux maintainers for SCTP, working for Red Hat.
Okay, I'll yield the floor to Subir, wherever you are.
Before we take Sabir, I'll just report back that 16 people said they agree with the requirements from the design team and no people said against it. So on this basis, the working group is going to accept those requirements as the basis for doing the work. I'm going to start another poll suggesting that the design team might finish, but I'd love to hear Sabir in the process while we're carrying on discussing this. So please take the poll, please also get the questions. Go ahead, Sabir. Go ahead, Sabir.
Subir, are you in the room?
using the local tool.
Okay, I'm going to remove you from the queue. Feel free to rejoin.
Tira?
Thiru from Nokia. For option C, the only contention seems to be with regard to the new draft in the TLS working group, but the only contention there was with regard to whether this needs to be done in the TLS stack or in the application layer. Once that is resolved, it's pretty much a very small change where we just have to exchange a couple of messages for the new key exchange. And if we have the implementations available on Linux kernel or FreeBSD, we can test the entire solution. So it's a very minimalistic change to TLS. And if it's done in the application, it's just one message in the TLS stack, which anyway, 2 layers of security communication is already happening because in TLS 1.3, we have post-handshake certificate authentication happening in the application layer already. And they have already done that in the past. So what I see is a mixed reaction where there's, at least in the list, there were several people who were proposing that we have done that in the past and it worked for us. But today in the working group session, there's quite a bit of comments saying that we should move back to the TLS stack and do the new ephemeral key exchange in the TLS stack exchange itself.
John, I think it's the right decision to move it back to the TLS layer for several reasons. I think my understanding is that that will impact the TLS key schedule. My expectation is that the TLS working group will require formal analysis of that. My expectation would be that at the year, so my personal opinion it would be that this will take longer than 25, but my guess is as good as anybody else. But I definitely think it will require formal verification before TLS publishes this.
Yeah, I mean, it will require some formal analysis enhancing the existing ones, but the new keys will be derived after the existing keys are derived. So, and they will be using the same key derivation functions. So it's going to be the same ephemeral ECDH key exchange. So I don't see a major change in the way formal analysis needs to be done. But I think we have to wait for the document to get adapted and then the discussion to happen in the working group how the progress of the document can be accelerated.
Okay, on our poll, it appears that only one person said there are additional topics for the design team. I suggest that person contacts the chairs. We are terminating that show of hands. We conclude that the design team has done good work. Thank you for everybody who's being a part of that. We have decisions to make by the working group, so we expect to close that design team. Okay, I wonder, Magnus, if it's worth asking if people could be content with if people would be content with having more than one solution.
Yep, we could ask that.
I think it's a useful question at this stage. We've heard pros and cons with very different timescales. So I'm going to set a poll up to ask, is there an appetite to work on more than one solution?
So, John?
Yeah, I think it might make some reason to discuss which two solutions. I think solution B is quite different from solution A and solution B. A and B are
A and C, you mean?
A and C are DTLS over SCTP with some change. B is DTLS in SCTP. So I think, but now I think the assumption here is that A is scrapped, and the question here is really is there an appetite to move forward with B and C? I think that makes maybe more sense than the general question.
Okay.
Jahed,
So take this question in the context of progressing with the two design strategies we've had of B and C. Please comment now if you wish to, and then I'll ask Magnus if there are other things you would like to bring up as we close the design team, and then we will take the discussion to the list. So now is the time to join the queue if you'd like to contribute to this discussion, and I also will ask Magnus if there's anything else he wishes to ask or clarify. Go with the queue first.
This is Jahed here with no hat. I think the question about this appetite for two solutions. I think what I see, we have very hard time getting reviews when it comes to SCTP and related work. So I'd be rather cautious saying like we actually go for two solutions without really further analyzing or asking the question like whether we can deliver on more than one solutions or not. So that's something that I'm a bit worried about. That's my opinion. So my option, so I'll choose for like no opinion here.
Martin Duke, I second his concerns about bandwidth in the group for that, but also like our whole purpose here is doing operable specs. And I think if there's like the Ericsson boxes are doing this thing and like everybody else is doing this other thing, then we've kind of failed. Maybe that's a too simplistic view and there's some sort of way to fudge that, but my initial reaction is that's the opposite of a standard.
So, I mean, we're doing this to deliver a solution to 3GPP for adoption by 3GPP. So it will be up to the vendors of 3GPP products to implement what they adopt. So,
right, but the hypothesis here is that, so to like tie together this whole thread of like weird questions I've been asking. So clearly Ericsson would strongly prefer to do A, and the hypothesis is that OpenSSL will not do A, and so OpenSSL, if we had this other thing, would do C, and everyone else is built on OpenSSL. So you would have like one important market player who does A, and then everyone else is doing C, which does not seem like a much of a standard, in my view.
I think that's a misrepresentation of the likely scenario that happened. But yeah.
Okay, I mean, you know infinitely more about this market space than I do. So what would happen if we had two standards?
3GPP would pick one.
Okay.
Yeah.
And that's the only market for this. So essentially, we have a dead RFC, or one that's abandoned if they. Okay.
Yeah.
Thanks.
Yeah. Okay, I'm going to close the poll in 30 seconds. So if you want to express an opinion in the poll, please do. Go ahead in the room.
Thiru Nokia, I think we should focus our energy and pick one of the solutions rather than working on two. That will at least focus the energy, and then we could use Hackathon to do some interop as well, right? And the kernel implementation can be just one. So I don't think we have that many number of resources to work and develop and interop two solutions at least.
Yeah, answering to Martin that said it would be only Ericsson. I think here in the room we had support also from Huawei saying that they supported B, and the LS from 3GPP, which is the only answer we have from 3GPP, is that 3GPP supports solution B. I cannot talk for 3GPP, Nokia cannot talk for 3GPP. That's the only thing we have. And also the time aspect. I think it's essential that we deliver something to 3GPP in the timeframes they have requested.
Jahid, I just want to make one thing note to the working group is like when John said 3GPP went for B, at that time 3GPP didn't have a look on C. So basically, I think we should not really take that comment by analysis very seriously without asking them again between B and C.
I would like to point out that deciding to move forward with two documents at this point doesn't mean that we are committing to publishing two RFCs. We could just postpone the decision to a later IETF meeting when we hopefully have more information to make an informed decision. Maybe because the TLS working group has moved forward, or we have heard more from 3GPP and they have considered option C and how that impacts their requirements.
Yeah, answering to AD, I think as long as we haven't heard anything from 3GPP, I think what we have heard is what we should assume that 3GPP thinks. Yeah, and also like there is nothing indicating that 3GPP should have changed the reason on the timeline. To the contrary, Charles Ecker had been in 3GPP and discussing, and the timeline is still, it's very essential to ship something now. It should have been shipped yesterday. So like, yeah.
So I would like to associate myself with Martin's comments about being able to defer the decision. But what I like, one thing I like what you said, you laid out some actual criteria on like things we're going to figure out rather than just waiting for like this magic thing that makes it all clear, because I don't think we're ever going to get that. Like whether we adopt it, I mean, so clearly we can continue to work on both drafts. Like we have proponents for both of them, we continue to work on them. I would hope that we could develop some criteria. You mentioned TLS. I mean, this is probably just done on a list and on the mic, but if like somebody in this space could maybe come up with a list of questions we would like answered, I would personally like to nominate OpenSSL and consumers OpenSSL somehow being involved in this discussion, because that seems to be most of the rest of the market space. You mentioned TLS working group. That's obviously key input through GPP. I don't know if we're going to get an answer out of 3GPP in some sort of fixed amount of time. But
yeah, a question there, Martin. You're saying involving OpenSSL. Isn't their answer fairly clear? Aren't they very precluded against any IPRM covered solution?
I don't know. If they are, then that saves us time. If we're willing to grant that they will just absolutely not do option A.
I think
B. Sorry, yeah, we got rid of A. Okay, I mean, if you're confident in that that they're just not going to do B, then I think that essentially means that the only way that there could be two products that use this would be for someone to choose to implement it from scratch with the licensing, right? Because OpenSSL will no longer be a substrate for it.
You need to find someone to implement it, and that could be an open source that's you license, but yeah, it's not one of the maybe the classic.
Yeah. Okay. Thank you.
Thiru, Nokia, I think it's a good idea to involve OpenSSL to see if they would implement this. The other comment was, if let's, I'm not sure how 3GPP is going to evaluate the documents that are produced here, right? I mean, are we going to give some analysis for them to help understand the pros and cons of each of this and they pick it? And it's surprising to me that the document is produced here and we cannot prioritize, and we are letting some other SDO prioritize when HTTP, TLS, and all the protocols are being developed in IETF itself. So I think there should be some prioritization done here, and rather than just relying on 3GPP to make a decision, because I asked for the analysis for option B on what technical security formal analysis was done on option B. I didn't get any document from 3GPP SA3 either. So I think if they have not done it so far, how do you think they would do something differently than us to technically evaluate that one technique is superior than the other one?
I mean, an alternative, if you think 3GPP is the only actual consumer of this, we could just say, yeah, you will have to fix it yourself. We're not going to do anything. That is an alternative.
So that last comment just kind of made me sort of realize. So we essentially have one customer of this, which is 3GPP. 3GPP has a much broader, has all these stakeholders that we're talking about, the end consumers of this. So this maybe is a good question to them. Like, do you want it now, or do you want one that is more likely to have a variety of suppliers, right? Because that's the real question. And there are people who are going to buy this equipment that will get it faster, or they will get it, frankly, more expensively, just because of the way economics works, right? And like, I don't think we can't make that value judgment here, I don't think. So maybe we should just ask our customer, which is the SDO, what they want. And part of that is kind of, I mean, going through the technical implications of option C, and another part of that trade space is the technical trade-offs. And you know, you've made those cases. I feel fairly comfortable that B is probably technically superior to C in like an IPR neutral world. But the economic considerations, I think, are the competence of 3GPP, not us.
Okay, putting a chair hat on, we need to tidy this up quickly. I don't want to cut the queue, but I would love to try and be quick here and keep some working group time for other discussions. So go ahead, Turu and John.
Nokia, I'm not sure how we have concluded that option B, assuming patents are not there, how option B is technically superior than option C. I don't think I have seen any such analysis so far. So I would be really interested to see, assuming there is no IPR in the world, right? How option A versus all the three options are meeting all the requirements that we have specified, right? There are advantages in all the options. There are disadvantages. There's no clear winner, at least, right? But to say that one option, at least among option B and C, saying that one is a clear winner over the other, assuming IPRs are not there, I don't agree with that.
That was Martin Duke's view. That's his personal view. I share that view of B being superior. We can discuss that maybe later, etc., or if you want to have it now. But yeah,
we should have that discussion to figure out which one is superior in case if you want to pick that. But I don't think that analysis was done.
Okay, to clarify, I said that as a very weakly held view. I claim no expertise, and but so yes, we should have the discussion, and I'm very persuadable on that point. To be clear,
John.
Yeah, I would say the option B is simpler. It uses TTLS like for everything, and that's almost everything, and that's it. I find it a bit weird that there is so much IPR discussion here. Charles Ecker, which is our 3GPP coordinator, just said that 3GPP doesn't really care about IPR. There was no comment about IPR, and we just concluded that our only customer is 3GPP. So
okay. Well, we could conclude that SCTP is only for use by 3GPP, but I don't think that's the discussion we want to have. So there is a wider scope than our main customer for this, and the working group has to think about whether that is important. That might be the only reason that the chairs would consider progressing more than one specification here, because we have an IETF perspective of producing an open standard and a need to support 3GPP and produce a standard that meets their goals. I think we haven't quite determined the outcome from today. I think we have made significant progress. We have also focused a little bit more on the things we need to decide. We will not be adopting anything at this meeting. We will expect this to progress now more quickly because we have started this discussion. Please continue it on the list. If we do need an interim, we can organize an interim to keep the momentum going, but we will need to decide which of these documents we are going to progress towards an RFC. Thank you everyone for inputs. We have a lot of inputs here, and please continue to work on this because whichever way we go, everyone has agreed that it's urgent to work on this topic. Thanks, Magnus. Okay, taking my working group chair hat off, I will give a very quick update of careful resume to allow time for other speakers. So next slide. There's been a number of rewrites and revisions for this draft in the last period. The reason for presenting this slide is mainly to show that the spec has now landed in some respect. So we are looking at a number of implementations, and we are looking for people to read the spec, to implement it, to talk about it. And specifically, we've added QLog support with help from Anna, Robin, and Lucas. And I think that is a very significant step forward because it helps with analysis as well as checking the correctness of the code. Next slide. The QLog spec looks like this. I realize that QLog is a thing that's evolving as we speak. One of the interesting things perhaps is that this is probably the first QLog definition outside of the quick working group main specs. So things might change again. The good news is that we have some people developing tools against this, and we can have tooling now that if you approach people, will actually supply that tooling to help you do the analysis. That's probably going to be updated in the next rev. So next slide. We have a number of pending edits for the QLog to align the definitions with the spec itself. Hopefully the editors will get together and publish that in the next week or two. People have also started some unit tests. So those unit tests have discovered one or two corner cases. One is on entering recovery. It's possible that the Seawind goes to a very small value, which seemed like it was not a desirable outcome. And an extra if statement was added, a conditional, which I think is a good thing. It helps to ensure that the algorithm converges towards a sensible Seawind when your application is very bursty. And I guess if you haven't read the draft for a little while, it's interesting to look at Appendix A, where we now have a table which shows the transitions between the different states. And I think that's probably the most easily read part of the draft. So do have a look at Appendix A. Next slide. Where, as part of the people who are trying to implement it, are completing some unit tests. We have detailed tests and also summary tests, and we're working our way through those. We're nearly through. We will update the QLog and publish very soon. Thanks for all the people who inputted that. And we're also going to do some analysis with high BDP paths to see how this actually gives real benefit. So we'll have performance data for the next IETF. We'd love feedback. There are implementations based on a fork of Quiche. There's implementations in PicoQuick. And we're interested in anybody else who's willing to play, try, or even just interrupt the clients with a working sender implementation. And we expect to have very significant progress for the next meeting and hopefully have a working group last call. Any questions or comments?
Hello, Lucas Pardew here. I see Martin Seaman in the queue. He's probably going to make the same point I was going to make, but well, let's see. So regarding specifically the QLog stuff, we have been working in the last week or, well, yes, last couple of days even, on finally getting around to answering the issue about extensibility and clearly creating a way for documents such as this to extend the QLog core schemas. Like you were suggesting, this is one of the first concrete examples that is being done, which is great. There's a pull request in flight. We'll be talking about that stuff in quick session tomorrow. And ultimately what we'll have is like a template that the spec can then just use, effectively just defining a URI of your schema that extends QLog. And it's probably just a URN, since this is a document. I can't remember if this is standards track or not, but as long as it's an RFC, we can register it in the new proposed namespace that we want to do. So once we've done our stuff and got that in order, I'm happy to help
update this one, but we probably want to make sure that this documents working group last call does the right thing that we want for QLog before it's done and dusted, if that makes sense.
So when do you think that timing will be?
We have a couple of open questions that we need some help from people like Magnus to answer, specifically because we're copying how RTP did some of this. And we hope to get that done ideally by the end of the week or next week. So very, very soon, probably well ahead of your schedule. But I just wanted to flag that it might take us a little bit longer, but we'll help you.
Thank you. Help from anyone is always appreciated. That's great. Martin?
Very, very excited to see QLog used here. Thanks for that. One clarification question. When you said you implemented it in Quiche, is that Cloudflare Quiche or Google Quiche?
It's a fork of Lucas's repository, I think. We can send you details. Lucas, do you want to comment?
That would be Cloudflare's Quiche. So.
Yep. Okay, we'll use the list to talk about this. I'd rather give way to let other people have working group time than talk more about this. But really, I am keen to, as all the other editors are, to talk more about this and try and get this spec finished. Thank you, Martin. So putting my chair hat on, we have a couple of presentations. We're going to use the remaining time to talk about these. One significant thing that the chairs have pushed back on both sets of slides and their authors is to try and think about the requirements and the implications of doing the methods which are being talked about. And at the end of the session, if time permits, actually in the meeting room, otherwise on the list, we'd like to think about whether we can capture the requirements across the board about how to signal to the network the intention of the application, or whether this is a thing that the IETF has guidelines for or recommends. So go ahead, John, you're the first to talk.
Thank you. So this is a draft that we've presented before, but as Corey just mentioned, it was with the focus on solutions, and here we're talking about the requirements. Sorry, is it a bit better? Yeah. Okay, so this is the media handling considerations for wireless networks. If I can go to the next page, please. And okay, so we've pulled out requirements for the signaling into these 4 categories. Metadata for the media frames itself. What are the requirements for the media frames? Similarly, for if we're classifying it into media streams. And then independent of streams or frames, there are a set of requirements that relate to helping the traffic shaping in the network. And then finally, we talk about the channel or the transport requirements for it. Just as for context, I just wanted to say that there are a lot of aspects around the control signaling and so on, which we're not covering in here because it's already there. And we wanted to focus on requirements that we wanted help with on communicating these metadata. So that's the focus of it. But at the very last, we have non-requirements and a slide there that I've added to just convey a few common questions that have been coming up. So let's just go with all of the requirements. If we can go to the next page, please. So just as an overview, I think people are mostly familiar with this because it has been presented before. The problem is that in sub RTT time, there are significant variations, and that causes the traffic shaper or scheduler in the wireless network to drop packets randomly or at the tail, which results in unexpected behavior and not a pleasant outcome. So what 3GPP has worked on some solutions or trying to address some of these problems and ask for solutions. But here we're looking at what the application server can provide to a wireless router to help with this. And now considering that there are frames that we want to deal with and not packets, the requirements here are basically saying we need to identify the media frames. So that's one of the requirements, so that we can treat the packets of a media frame in the same manner. And then the related requirements are the two on relative priority of the media frames. So one frame is more or less important than the other, and that can be used to determine a drop priority when congestion is high. And the last one is tolerance to delay. If a packet can tolerate more delay or less delay, that can help the shaper or scheduler to optimize the overall outcome. So that's the one for on a per frame set of requirements. On the next page, I think Magnus has a question.
Yeah, on the previous slide. You have that saying that the you get random drops. I mean, isn't the most likely cause of packet loss towards them is there's some that link could cause that would fail, recover, repair, etc. But is in this case, and what you can actually use any information, etc., to deal with is you will not be able to deliver it within a certain time scale, and therefore would have to drop things. Isn't that what you're actually after?
Yes, it's yeah. I think the whole scheduling thing is pretty complex, and it's an oversimplification to say random. I guess it would depend on the schedule and the time frame and latency. Yes, I agree with that. If you go back one slide, please. Yeah. So in this case, unlike separating frames of a particular flow, what we're writing requirements for is to identify a set of media streams that may be transported in a single flow, a channel. So that could be like a WebRTC case where you have audio or video and so on, so it's the same set of requirements. We need to identify the media streams in this case and not the frames. But then once you identify the streams, it's the same question. The relative priority of each of those streams, and is one stream more or less willing to tolerate delay on the wire. So it's very similar to that. And then I'll just go on to the next frame. So this is related not to a particular frame or a stream. There are a few criteria: burst size, jitter, and packet loss, which we're talking outside of a single stream or frame. It depends on how the server or what kind of media arrives and how the server sends it, that can cause varying amount of burst and burst intervals. And it would be very useful for a radio scheduler to have the burst interval and particularly the burst size ahead of time, or so that it can act to reserve resources more appropriately. So that's the burst size. We haven't specified burst interval, but we can talk about it if we need to have it. And then we've also asked for a couple of other things in the requirements, that is jitter and the delay, the detection of lost packets. The reason we want to know about lost packets is to identify the beginning and the ends of a frame. And the jitter is useful also for scheduling. If something is coming very late, then in relative terms, there can be some adjustment done in terms of shaping and forwarding. Is there a question, or can I go?
John, the requirement around server telling the burst size to the network, how do you think that'll play out for live video, where, I mean, as video is being generated, it is being delivered. So oftentimes you don't know what kind of complexity of the video is going to be ingested on the ingest side.
Okay. So I was assuming that the server, I mean, this is precisely the case where you want to know it, because if it's very periodic and predictable, then we can convey that. But it's specifically for, in this discussion, I mean, maybe we should have this discussion offline to see if that is providable or not. And if it is, it would be a very useful parameter to have, because the scheduler can adjust or reallocate resources, potentially. But if it cannot be provided, then yeah, we should note that too. Thanks for that. If we can go to the next, please. Okay, so the next two slides are about privacy considerations, and then scale and things like that, performance and scale. So in terms of privacy considerations, I mean, the figure is trying to show that the metadata goes in a separate channel than the media itself. So the media itself is not affected in any way. It is fully encrypted, and no one in the network has any, does not see anything about it. So what we're talking about is what privacy does the metadata need to handle. And one of the broad considerations that we've put in is that it should reveal no further information about a user or the content. But I think we perhaps need to enhance this a bit more to say all the privacy considerations from 6973, for example. And that's something we may look at. But I just wanted to say that many of these fields are more like an enhanced DSCP. And we need to do a full security analysis to see how much can be sent. I don't believe it's just about encrypting the channel. It's also about what will be revealed to the wireless router or anybody on path. So we have to work on this a bit, and I would appreciate any help on that. So going to the next one about scale and continuity after handover and so on. The point we wanted to make is that since these mechanisms, I mean, this is like QoS and it's sent per packet, we need to consider how these are configured. We should not have a configuration for each flow. And it should also be able to have a minimal amount of state information so that the router can handle all of these things effectively. And also after handover, it should not take a certain amount of time to reconfigure all of this information. So I think we've put it as induced latency in after a handover and so on. So these are the other set of requirements that we have. And those are the set of requirements on the next slide. If we can go there. Yeah, I think what we have is under non-requirements, but these are some assumptions we've made. But I've seen that there's a lot of discussion and a few questions on the list too that have asked the question more or less, is the end user aware of these things? And or can the server modulate what is being sent? And I just wanted to clarify that, these are, table stakes or baseline assumptions that we made, that, it is not that the server sends random stuff to optimize. There are agreements. If you look at two scenarios that we have, in scenario A, it's more like a 3GPP network where a connectivity session between the 3GPP client and the wireless router or the UPF is made. There is an explicit agreement to provide a certain set of conditions and services. And similarly, there is a provider agreement between the server and the wireless. So it's a transitive set of these that allows these metadata to be sent. So it's not some random stuff that's sent on the network. And even in the case where there is no such, if you have an open network like a Wi-Fi network, there are maybe provider agreements between the server and the wireless, and an application signaling can confirm whether the client is willing to have these kinds of metadata disclosed. So there is an end-to-end mechanism, and the client's preferences are definitely considered in these cases. Just that the focus of these requirements are not these over-the-top and control aspects, but rather the how do we get these metadata to the traffic shaper. That's a focus, but and we're assuming that all of these other things can be easily solved or have already been solved. And similarly about the server, I just wanted to say that the server can adjust the rate or not provide things. I mean, it has a lot of feedback. For example, in good conditions, it may just not provide any information or provide that everything is equally important. But when it notices that there is congestion or drops or whatever, it can change the profile. So it's completely under the control of the application of the client. And so it's relatively immune to misuse in that particular case, at least. So just to answer a few questions on that. And I think that's about it. In the last page, we're asking, I mean, we've been discussing this problem. I think we have a stable set of requirements, and we'd like to see if the group can help us improve it, and also if we can adopt and work on it and see how we can progress on this. Thank you.
Zahid, go ahead. Be brief, please.
Jahid, so John, I mean, just for my information, how much of this has been discussed with media folks like in AVD Core, MOPS, how much they have looked into these things? Because some of the questions about like sharing burst information, figuring out packets belongs to the same frame is very critical, very because the whole requirement will depend on those kind of things.
Right. So this is something we'd like to get help on. So we haven't discussed it in detail at all, as you can see from the question also about burst size, for example. Where we have gotten feedback, I mean, it's not that we don't have any feedback. There have been discussions between SA4 and SA2. So SA4 discusses media from the 3GPP point of view. So there have been lots of liaisons back and forth about delays, burst sizes, what can be provided. I think they're thinking about extensions to RTP, for example, on all of these.
That's fine. That's fine. But we can
we
just rely on those kind of analysis. I think we need to get feedback here in IETF from different kind of media experts, personally or working group. Maybe you can have presentations in MOPS and also like AVD Core. To get some feedback, because this is really important that we get these things in a way, in a shape like reviewed by experts, so that it's actually doable and useful, right?
Absolutely. So, I think there are different stakeholders, and we do. I completely. Thank you. We're looking for feedback.
We have one more presentation on a related topic, so we need to close the queue. And if you ask questions now, you're going to delay the process. So please be very quick in your questions. Ingvar.
Okay, do you hear me?
Yeah, go ahead.
Yeah, great. I have a question actually going back to this slide 3 here. And I get the impression here that you're talking about coping with fast fading and scheduling in intervals and that stuff in order to keep the queue very low. And I want to clarify, for instance, the role, for instance, with Del4S is that you push the bitrate sufficiently low to cope with this fast fading sufficiently enough in order to avoid getting a large queue that you need to drop. But I believe it's a tall order to try to cope with this 1 millisecond variation in throughput in this case, and drop packets based on that. But I'm not sure what is the intention. Is it to drop packets when you can't meet your schedule in the next millisecond, or?
I just a very quick answer to that. I think the idea is to not drop packets, really. You know, this is to give information that will allow the scheduler to use this information in the best way to delay, reorder, whatever it is. If the drop packets is like the worst thing that can happen, but
yeah, but I
if
guess
it has to, then,
yeah.
I'm sorry, if it has to, then it should drop. I mean, all the packets. I mean, if it's 50 packets of that same frame of low priority, then it should drop that, and not just drop 2 or 3. That's the point.
But I guess you already have the quality of service framework that you can use, and you can direct those really sensitive flows into one specific DRB, data radio bearer, for that purpose.
Right.
I'm not sure how this fit into what already exists in the 3GPP specifications, and so, but maybe we can come back to that later. So.
Yeah, I think we can talk offline, but I did not want to bring the DRB side of things. I think they do a lot of optional things there, but this is not just about 3GPP. I think it's also to Wi-Fi, and I've heard even the cable networks can experience similar behavior with traffic shaping. So we'd like to see a minimum set of variables that, metadata that is sent that is useful to all of these accesses.
Spencer, and please keep your question very short.
Actually, I'm answering a question from Zahed about where else this has been being talked about. So I'm one of the co-authors of the RTP over quick specification in AVT Core, and also co-author with John. It's also worth mentioning that people like Mach and things like that are shooting at a longer time frame for feedback than what this draft is talking about. You know, if you've got time to do RTT, you know, for end-to-end RTT feedback, that's great. This is trying to shoot for things where you don't have time to do that. And this is actually coming out of, you know, if you look at the 3GPP discussions, they're mostly talking about RTP rather than anything that you'd be doing with live media, as is discussed in the IETF. Thanks.
Thank you.
Kenji, CMCC, yeah, here. Just try to, you know, I have been working with the same thing with Junkie and know all the background of this from IETF side and also from 3GPP side. Looking at this draft, it seems it's trying to generalize for the media transport. Now it's like RTP quick, media over quick, all kind of things. So as a Spencer side, this is important work. So really hope to get some fast track for this one to be adopted. Thank you.
Okay, I think we will take the next presentation if we can. You're going to have 4 minutes, so we've eaten a significant part of your time already. Please use that as best you can.
Yeah, so I will try to do it quick. So this is a presentation of the use case draft that will present that is capturing, I would say, some representative cases in which we need some collaboration between the host and the networks. Next slide, please. So this is just to provide a simplistic, I would say, scenario in which we are, I would say, referring to is basically, for example, there in various networks, there's multiple bottlenecks in the network. And basically, this is at the access part. So this can be your CPR router, it can be your edge router. And for example, in the cellular network, this can be the run part when there is a dynamic conditions there, which may lead to, I would say, overload on those resources. And then this will impact the overall available resources for your connection. So this limitation impact the way I would say the service is delivered to the client. So because of this limitation, there is some, as we can show in the next slide, please. The client or the host itself, under this constraint resources, it may want to instruct the network to say this: I would like that there are some differentiated behavior of my incoming packet. But the problem is that the network cannot honor all, I would say. If everyone is asking to prioritize his own packets, this cannot scale, and we cannot just inspect all the packets to do that. And in the other side, the network cannot partner with every server in the world because it is not scalable at all. And the other constraint we have there is that if you want something that can be collaborative between the host and the network, it should be deployable. And for that, there's a lot of trade-offs to be taken into account during the specification itself. For example, having the trade-off between the cost and the benefit of a given solution, the impact on the operation, we cannot just say that this will be just a simple bit that we can convey to the host. There are a lot of hidden complexity in the architecture. And also the benefit we may have by enabling this kind of signaling, we need to have also distortion on the nominal mode. Next slide, please. So this is just, I would say, the in an overall sketch of the one way to do this collaborative signal between the host and the network itself is that the receiver itself, it can just pick few flows or packet within a flow to say that's this is the flows that I can send some metadata with these flows, so that the network can be prepared to handle them. And then at the network side, when there is conditions, for example, I'm overloaded or I'm under pressure, then the network can deprioritize some of the flows based on the metadata which is provided by the host itself. So this is not this is done only when there is a reactive policy event. That means that I am in a pressure and I don't have sufficient resources to handle all the flows. And all of those conditions should be handled while taking into account the operational considerations of this signal. Next slide, please. So this is just the example of the signal which will happen. It will happen between the elements that are, I would say, that will represent the bottleneck. Next slide, please. Yeah, this is just example of the differentiated treatment. So this can be happening at the network side, just to implement what you call the packet discard preference, or at the host. The host it can adapt the transmission to the metadata which is provided by the network, or it can migrate the connection to another path if there is the one in a signal is received from the network. Next slide, please. Yeah, so this is just to say that we don't need to reveal the application identity, the server identity. We don't need to disclose why I'm sending the metadata. I don't need to inspect the packet themselves. No decryption at all. Next slide, please. So this is just to provide an example of the hidden operational consideration behind some simple bits that we can convey the signal itself. For example, if some of the use cases we have suggest that we can send, for example, the maximum bit rate in a flow, but there's a lot of complexity there. The networks, they don't have any, I would say, per quota per application or per flow. So what should I send there? The limits are not per host, they are per subscriber. I don't know the number of the hosts that are bound to a given host. So again, how should I compute that? The same node, it's servicing multiple customers, and all these customers may have different service offerings. So there is no system-wide configuration that can convey in this kind of signals. So there's a lot of, I would say, a consideration that can be taken into account there. Next slide, please. Yeah, we can just move to the last one.
I think we need to move to that slide. Yeah, and maybe I could ask this slide. Thanks, Med, for doing like a million miles an hour presentation. It was useful just to see your slide deck. From the chair's point of view, we've seen a number of short presentations of this over many IETFs. And I think I really do like the idea of understanding the requirements, understanding the what the scope should be if the IETF does proceed in one of these ways. So There's not time for you to take questions this time, unfortunately. We can discuss this on list. I wonder if you and John might be encouraged perhaps to produce a common document that talks about two very different use cases, but actually drills into that interaction between the network and host and the host and network. You can comment now or on the list, but if you're interested in producing one common document, I think that is something that we could actually put earlier in the agenda and give you time to discuss that next meeting.
Gary, can I quickly comment?
Go ahead.
Yeah, I think Matt and I talked before, and these use cases are complementary because here in this draft, they're talking about host to network, and we're talking on the other side from the application to the network. And those, the flows over, control flows can determine which is which. We can definitely create a use case that is common. So I'd be very happy to work on that. The requirements may be different because sometimes because there's uni and PNNI kind of networks, so yeah, we can definitely do that. Yeah. They're complementary.
Just to be clear, John, I'm not asking for one set of requirements or even one use case. I'm asking for one document that talks about the issues of trust and the issues of signaling and what sorts of metadata might be involved, and there might be more than one of those that are needed to solve the different use cases.
Yeah, I think we can work on use cases, yes.
Okay, thanks. That's great. We're going to close the line. We're already out of meeting time. Thank you for these two presentations. And thank you for being at Brisbane at the TSVWG meeting. Martin, do you have any final comment?
See you all in Vancouver.
I like that comment. See you all in
So,
Vancouver.
Jahed, I have a comment for Martin. Thanks for doing the service.
That was super.